Hello, this section is entitled Deploying an Application, Updating Scaling Configuration, Versions, and Traffic Splitting, but this time we're using Cloud Run. So Cloud Run is very similar to App Engine's flexible environment in this respect that it is built on top of containers. So you basically build a container and you're deploying a container inside of some container engine that Google manages. The pricing is a little bit different than App Engine. They actually quote it at a price of at vPCUs per second, or for each second. But if you do the math, it ends up being a bit more expensive than App Engine. So it runs about almost over 8 cents an hour per vPCU. So that compares to about 5 cents per hour for App Engine and about 2 cents per hour for just Cloud Compute Engine directly. So you are paying a premium for this. Now, one big difference between this and App Engine Flexible is you could actually scale to 0. That was not an option in App Engine Flexible. So this is containerized, but you're not actually paying for like an instance always, right? You can basically scale this down to 0. So that's one. Maybe that's why it's more expensive, because you can, it's cheaper because you don't have to run it all the time. So it just really depends on what kind of workload you're running in terms of costs. So in terms of the containers, if you remember, we used a Docker file previously, so we do the same thing here, except for this time, the requirement is that you do respect the port environment variable. So you need to basically set the port that your application is listening to the port that's supplied as an environment variable to your Docker image. So that's another difference between this and App Engine Flexible. Okay, I think really, another difference here too is that you actually build your container yourself. So you don't. So with App Engine Flexible, when you're deploying, it actually did the whole thing all at once. It took your code, took your Docker file, and it built it as all one step and deployed it. Here, what you do is you separately use a different tool that Google provides called Cloud Build, and it actually just builds Docker images for you, or images. And so that's a separate step. And then that's technically nothing to do with Cloud Run. And then separately, what you'll do is you will actually then deploy that Docker container in a separate step. So I think the best way of doing this is by example. So let me go into the code. So here's our hello world example. Look at what's here. So the server.js is as we saw before, except for this time I am going back to using the port environment variable. So that's familiar. Package JSON. I just use the default package JSON. You can put the engines in here. It's not required because the build process doesn't depend on the engines being there, whereas we saw earlier it did. And let's see, Docker file. Docker file here, I don't explicitly say what port I'm exposing because they're going to supply an environment variable. So that just FYI with Docker, when you expose a port, that's mostly just informational. It doesn't actually do anything. So in this case, I'm just remove the expose 8080 because I'm not guaranteed to always be running on port 8080. And I did slip in one extra file that they talked about. There's a Docker ignore, which we could have done before with the other example. So when you build a Docker image, you don't necessarily want to copy in files that right? So for example, when you're doing the build, for example, you don't want to copy in your node modules. You want to actually copy in your package files and then have inside the Docker container you want to build the node modules fresh. So you don't really want to start off with copying in a bunch of files into your container. So this was something we could have done earlier. This was discussed in the examples here, so I added it. Okay, so you pretty much have a folder. I haven't done anything with Cloud Run yet at all. And the first thing I want to do is build an image. So let me copy and paste this and then we'll talk about it. Because there's a Docker file here, I'm running gcloud build, and then I'm submitting it. I'm basically going to build it, and then I'll turn around and I'm going to store that image under this. This is part of what's called, we'll see it in a minute, but this is part of Google Cloud Repository, or no, Container Repository. And the format is GCRIO, this is your project ID, and then this is the name of your image you want to store, and then you want to do a version. So I'm doing 010, right? So if I just hit this, this is going to basically send this over to Cloud Build. It's going to basically spend about a minute or two building a container image and then storing it in Google Container Repository. So let me pause this until we're done. Okay, I'm back. It only took about a minute. So basically it's stored basically in Cloud Repository or Google Container Repository. It stored my image. And just to show you what that looks like, I can actually go to Cloud. And if I search for container registry, I think it's container registry. Oh, it's container registry. Well, it's funny. It's called container registry, but then you basically have repositories. So a lot of R words. So what you're seeing here is, see this hello world right here? You can see hello world, and then there's this is my container image, and there's the tag 010. Now, if you look carefully at this, you notice that App Engine under the hood, when we're deploying things, looks like was actually deploying images for all of my code. So there's like 6, 7, 8, right? So this was all on top of the flexible environment. That's what these were. And then I wonder what's under this one. Yeah, so it looks like when we were on the flexible environment, it was building container images. When we were on the other environment, which was the standard environment, it wasn't using container images, and that makes sense because that was the distinction between flexible and the standard. Okay, well, that was just a sidebar. So right now we're not doing anything with App Engine. Now, just to show you, not App Engine, I'm talking about Cloud Run. Now, I already activated Cloud Run API because I was doing an example of this before here. So if you were to come here, I think you had to click the button to enable the API. So that's the first thing you do. And you see that they have a concept called services. So I think the next thing we want to do is talk about sort of, we got an image, but now what's the structure of all this? So let's follow a link. I heard this right here. So similar to App Engine, right? There's a hierarchy of resources that you have, right? So I think there's a picture here. So within a project, which is the gray block, right? You have services. So just like, so there's one less layer, right? Before you had the application with App Engine, you had application and you had services. This is just project, you just have services. So this is part of Cloud Run, you have services. And then within any given service, you have a particular revision, which is basically a version, right? And then, of course, under the revision, you have the container instances. So this is a very familiar pattern when you looked at App Engine. You have basically these same three concepts, right? And then we'll do things like splitting traffic between revisions later. Okay, so that's the basic structure. So right now we have no services. So that's kind of expected since we haven't deployed anything. So the next command we're going to do is we're going to deploy that container that we built. So yeah, let me copy and paste this, and then we'll look at it before I submit it. So paste this. So now it's gcloud run deploy. So this is part of the Cloud Run. I'm deploying, and I tell it what image, right? That was the image I just built. And then there's this platform manage means it's part of they manage everything. There's various flavors of Cloud Run, but we're only going to talk about the managed one, where basically you just take your containers and you run it inside of Google's workloads. So it's going to give you a little UI for walking you through the setup of it. So at minimum, you need to have a concept of a service name. I'm going to leave it the same as the container's name, so enter. You have to pick a region for that workload, right? Now, one thing that's interesting here is which means any service can be in any region. If you remember when we did App Engine for a project, the app itself had to be in one region, which essentially meant all the services were in the same region. Here, we're allowed to actually run each service in different regions. So that's another advantage of this. I'm going to use 19, which is US Central 1. This is an advanced feature where you can make this, you can basically force authentication. I don't want to mess around with authentication, so I'm going to say allow yes, allow unauthenticated. Now this takes a minute, so I'm going to pause the video again until this is deployed, and then we'll look at what happened. Actually, that was quick, so I didn't even pause it. Okay, so it looks like it's deployed, and it's saying this is a URL. So let's test this out. If I go to my browser, let's see. There's Hello World v2. Curious. Oh, yeah. I guess I had done some earlier. I had accidentally I forgot to remove the v2. So either way, we'll do a v3 later. So this is v2 for now, I guess. Let's look to see what that looks like from the perspective of here. We'll see a service. Let's see. Let this load. So hello world. Allow unauthenticated US Central 1. And that's basically all there is to that. So that's kind of the most basic example of first building using Cloud Build, deploying to Google Container Registry, and then we then took that image that's in a repository and we then ran it inside of Cloud Run. Okay, whew. So there is logging here. So one nice thing about Cloud Run is that they provide actually some nice user interface here. So the first thing you can see here is they actually have the metrics. They're just nice, laid out, really easy to find here. And logging, they also make it super easy to find. So you click on logs, and then there's all your logging, right? And there's probably my example app right here, right? So either way, so logging, and then of course if you want to look at in Logs Explorer, I think you can just say open a new in Logs Explorer, and you can see that it's a different kind of resource type. It's a Cloud Run revision. There's a service name, location, and then you get your same data. Okay, so it's a different resource type, but the same ideas. But they provide nice, easy GUI here to kind of find things. Okay, that's it for logging. Now, under the hood, we're going to look at a configuration. Remember, in this case, we never really created a app-.yaml, right? But there is something. Let's see if I can find it here. Let me close down the logs. I don't need this. I guess I need to go back to Cloud Console. I need to go to Cloud Run, Hello World. So there's I guess revisions we didn't look at either. So the revisions here are, there's only one version of it, right? And I believe we're going to look at this YAML here. So just like remember before, we had this service, the app.yaml that we were using for App Engine. Well, there is another kind of for Cloud Run. They have a similar text format that kind of defines everything about it, but it's substantially longer. But before I dive into that, there's something about this Knative business here. And I just want to talk about what Knative is. So what Knative is an open source project that's not run by Google. Google participates in it. And it's basically designed for companies like Google or Amazon or whoever's doing serverless, containerized deployments. It's a standardized way of basically doing that and exposing like a YAML format file that is common between them. So if you were running something on Knative on Amazon, and that you would be using a YAML format that was similar to Google's YAML format, as opposed to, with Cloud App Engine, you had this app.yaml that was very specific to Google, right? In fact, there was two different versions, one specific to standard and one was specific to flexible environments. Here, Knative is an open standard way of doing essentially serverless containers in the cloud, essentially. So I think that's all I really wanted to say about Knative. Here's an example of that format. So it's a little more complicated, and we're certainly not going to dive into all of this, but some highlights. I was going to show a couple lines here. One is, where is it? This should remind you a little bit of Kubernetes, right? You got containers, and then you got your images, and then in this case I have a port that I'm exposing, right? And we didn't really cover this, but there's also, you can set up limits on the amount of CPU your container gets and a lot of memory you get. Very similar to Kubernetes, but there's the image there. And then I think that's really all we want to talk about here, right? The point is that instead of instead of a Google-only version of the app YAML, we have now this Knative definition that's more of an open standard. Okay, so let's go back to our course. What do we want to talk about? So now we want to talk about scaling. So there's actually a command we can run. We can see this, by the way. We'll look at it in the YAML file here in a minute. But you can also get a kind of a shortened version of the. Let's see, it was Cloud Run. This is in 18. No, this is in. Where's US Central 19? So there's some information, there's some basic information about the service, right? So let's go through this because there's some important terms. There's the image, right? There's the port that that's exposed on, and then there is these here are related to the amount of memory and CPU that you're giving your container, and then we'll be talking about these three values: concurrency, max instances. There's actually a min instances that you're not seeing here, and there's also a timeout. So just for reference, those same values are also exposed in here, if I can find it. Let's see. Where is the scaling? Well, there's concurrency. Of course, I can't find it now. Min. I don't see the scaling information here. Well, we're not going to edit this here anyway. We'll do it some other way. But we're going to do it through the GUI anyway. But I'm pretty sure you can. I guess it maybe it's no value here, so it's defaulting. But you can actually come into this entry and edit it, and just directly, if you knew this format of Knative, you can come in here and apply the scaling changes. But we're going to do it a slightly different way. So let's go do that. But before we do that, there's a couple theory that we need to understand and see if I can explain it right. The way this scales is a little different than some of the other examples we saw of scaling. So first of all, just like before, you can set a minimum And if you set a minimum, it's always going to maintain that number of containers running, and then it can scale up. And of course, maximum is pretty clear. That's the maximum number of containers that you can run. Now, what's new here, at least, or who's new to me at least, is this idea of concurrency. So if you look, remember that previously we were scaling up instances based on the amount of maybe, like CPU load or latency, things like that. Here with what is Cloud Run, the way you do this, you say for a given container, how many concurrent requests a container can manage, and whatever that number is, I think it's 80 by default. So that what that means is if at any given moment, if there's 80 requests coming in at that moment, it'll stay on one container. If it finds that it needs to serve more than 80 at a time, like there's like maybe 100 requests coming in all at once, then it'll spin up another container because 80 won't fit on one, and it'll put the 20 extra requests on a second container, and then so on, right? So this is how it decides whether to scale up in the world of Cloud Run. It's all about setting the concurrency of your container. So good news is that Node can handle 80 simultaneous requests typically. So this is fine for Node, but depending on your runtime that you're running, you may be able to handle more or less concurrent requests. Okay, so that's the concept. So what we'll do is I'm going to show you how you might change that, not so much in the YAML, right? Maybe if you just do it sort of more the ClickOps way. If you go under Edit and Redeploy New Revision, you can see here. See if I can get this right. So if I scroll down, capacity, oh, here it is right here. This is the maximum request per container, right? This is the concurrency. So 80 is default. I didn't mean to change it, but okay, I'll keep on scrolling. And then here's the auto scaling. It's between 0 and 100 maximum. So this will scale down to 0. If you want to scale this, have a certain number of reserve instances always running, you can just change this to like 10. I'm going to hit cancel here, right? And what we want to do here now instead, though, is I want to show you how you might create multiple revisions of your application, and then we'll talk about splitting traffic between them, right? So what we're going to do is we're going to deploy another version. So let's go back to our code, and let me go to server.js. Actually, what I'm going to do is I'm going to revert it back to, I'm going to drop off the v2, just make it different, right? And then I am going to basically build another version, right? So what I want to do is I want to build another, if I can find my, build another, see this is run, I need to build version maybe 2.0, right? So I'm going to pause, this only took a second, I'll let it, I think I'm just going to take 10 seconds or so. Or maybe I should pause it. Okay, I'm going to pause it. Okay, we're back. So that just builds a container. It doesn't really deploy it, right? So the way we can deploy a new version is we just run the same run deploy. Now I did want to show you, you can actually do it from the GUI too. So if I went in here, let's see if I can get this right. I'm under Hello World, edit and deploy new revision. I can come in here and then just change this to 2.0 because that's the new image, right? Leave everything else the same and hit deploy. And then what that'll do is create a separate revision of the service. Okay, so you can see now it deployed the new version, a revision, and then it switched the traffic to it. So this is the old VUT That was the old one, and now this is the new one, right? So then the last thing to explore is, well, how do I split traffic? Say if I want to do 50-50, right? See this little button here, manage traffic? So you can basically say, instead of saying the latest healthy version, I can say I want to do 50, 50, and then drop this down to 0. I guess I have to literally put 0 here, I guess. Then hit save. Now I've got it's going to change the split. Not sure how long this takes. There it is. So now if I visit this URL, right, half the time, of course I'm probably caching right now, so that's not going to, I'm not going to see if I can get rid of this caching behavior. Inspect. I think if I just hit empty cache and reload, there it is. Empty cache and reload, empty cache and reload. There's a V2. So it is switching 50-50 between the two. So I believe, in sort of a roundabout way, we've covered all the major topics, right? How do we scale it, and then how do we split traffic between revisions? So that's it for this video. I can figure out how to turn off the video.